is recording. Hello, YouTube Nation. This is the first time we're recording 8th grade algebra. Does anybody want to give a shout out to YouTube Nation? Anybody want to say hi? Nobody. They're very timid. So if you're watching this, okay, Nico says hello. Hi. We're getting a lot of highs. Great. Excellent. What's up, YouTube, is what we got from Rand. Very good. Okay. All right. So please put your name at the top, Mr. Gens. At this time, I expect that everybody will have a pencil in hand. Everybody will be following along. You're going to want to make use of this. This is something where I can, generally get an idea of whether or not you're following along, paying attention. Chromebooks all the way down, please. All the way down. All the way down. There we go. Thank you. So today's date, we've got 2/27, and we've got 18, and section. This is the Pythagorean Theorem. I'll put THM as short for theorem. Today we're going to teach you how to do something. We're going to say I can solve right triangles using the Pythagorean Theorem. I can solve right triangles using the Pythagorean Theorem. Okay. First things first, what makes a triangle a right triangle? Does anybody know what makes a triangle a right triangle, Jared? Yeah, so you can see right here in our example that this has a 90-degree angle in it, okay? And we say that it then has two legs. This is one leg, and this is the other leg. There's a longest side in a right triangle, a longest side. It has a special name. It begins with an H. Does anybody know what it is? Hypotenuse. I can tell you more about that word tomorrow. Hypotenuse is the longest side. It's always across from that 90-degree angle. There's a very special relationship that exists when we have right triangles. And you've maybe heard it before. It is this. If we take this leg A and we square it, and we then add it to this leg squared, we get something. I heard somebody say it. C squared. A squared plus B squared is C squared. That's something that works in right triangles. Okay? Something that works in right triangles. Okay? Now, there's something else that we can do here to kind of, change it up a little bit. Suppose I were to subtract a B squared from both sides. What would remain over here? A squared equals, what do you then have over here? C squared minus B squared. Very good. Suppose that instead of subtracting B squared over, suppose you subtract A squared over. What would remain on this side? B squared equals C squared minus A squared. So really the Pythagorean theorem can be written in three different ways. And there you have three different ways right there. This is something that you won't just use for this lesson or for this unit. You're going to use this in geometry. You're going to use it in algebra 2. You're going to use it all of your life. In fact, if there's one thing that is really, really applicable to the real world is the use of right triangles. This is something you can definitely make use of. So let's try to figure this out here. I want you guys on your own, okay? I'm going to give you 30 seconds. I want you to try to figure out which side is C for both of these triangles. Don't say it out loud. I want you to try to write C next to the side of the triangle that corresponds to, okay? Take 30 seconds, try to figure that out real quick. Okay, you tell me. Did you get this side for C? This side? Yep, this side is C. It doesn't matter then which one you call A or B. I'll just call this A and this B. Okay? How about this one? Did you call this C? This one? This one. Yep, that's the longest side. It's opposite the 90-degree angle. You can call the other sides A and B. So every time we get a right triangle, we first want to label it A, B, and C. So this is A, this is B, this is C, this is my 90-degree angle. Okay? It says find the missing side and round all your answers to the nearest 10th place. So I'm going to make up a few problems that we're going to solve together. We're going to call A side length of 8. We're going to call B a side length of 15. What we want to do is we want to find C. Okay? Our Pythagorean theorem says A squared plus B squared is equal to C squared. Can somebody tell me, what do I plug in for A? 8. So I have 8 squared plus 15 squared is equal to C squared. We have to figure out what these things squared are. If you need a calculator, you're going to have to take out your calculator right now. If you need to use your phone as a calculator, that's okay as long as you're using it as a calculator right now. You won't be able to do that on a test. If you need to borrow a calculator, then you can do that as well. Anybody know what 8 squared is? 64 plus 15 squared, 225 is equal to C squared. Excellent. I need to solve for C squared. What is 64 plus 225? 289. That's C squared. I want to find C. If I want to find C, what do I have to do to both sides? Do you know? I take the square root. I take the square root. It means, what do I multiply it by itself to get 289? And for those of you with your calculator, you can start to check this out. You do have a square root button on there, and I'll show you where it is. Okay? I have this calculator, and if I go second square root, so it's that key that looks like that, I press then 289, and I get 17. So C is equal to 17. Okay, I'm going to have you guys try one on your own, okay? We're going to call this side 12 and this side 5, and I'd like you to find C. Go. Not quite fully getting it. We will work together on this at a different time as well. But does it matter which one you call A or B? No, it doesn't. I'll call this A, I'll call this B. We have A squared plus B squared is equal to C squared. What do you get if you square A? 25. How about if you square B? 144 equals C squared. So a lot of people get here, what's 25 plus 144? 169 is equal to C squared. What number do you square to get 169? 13. So you have 13 is equal to C. So your answer is 13. Okay, good work. All right, make sure you have those calculators ready. We're going to do 2 more examples together, okay? Flip it over. We're going to do 25 and 24. What's different about this example? It's so important that you guys decide what's different about the example compared to the others. Yeah, we gave you the long side this time, didn't we? Okay, we gave you the long side. and the long side is 25. So I'm just going to make a note here. Everybody agree that that's C? And I can call the other ones whatever I want. I'm going to call this A, and I'm going to call this B. Got it? Okay, I set it up. A squared plus B squared is equal to C squared. Do we know what A is? No. Do we know what B is? It is 24, so 24 squared. Do we know what C is? 25 squared. So you can see in the equation that you now have, you don't have a C squared, you have an A squared over here. That's no big deal. We'll figure it out, okay? A squared plus, what is 24 squared? Somebody either know it or come up with it on your calculator. What's 24 squared? Yeah. 576. Now I need 25 squared. 625. How do I solve that? What would you do to both sides in order to solve it? Subtract that 576 over to the other side. What is 625 minus 576? 49. What number is it that we square in order to come up with 49? It's 7. So this side is 7. Very good work. Ready for one more? Last example, then I can let you start working on your homework. You're going to get one homework assignment between today and tomorrow, okay? You're going to have 2 days to work on this. Got it? Okay, very good. We're going to call this side right here 6.4. We're going to call this side right here 10.1. What makes this one different from the others? Yeah, we have some decimals. And for this exercise, you're going to always put your answers to the nearest tenth. So that's to the first decimal place, the nearest tenth. Because we're going to come up with a kind of a weird number here, okay? And we'll just go with it. So we got to label our sides A, B, and C. What do you want to call this side? Okay, we'll call it B. I heard somebody say B nice and loud. How about this one? Can't call it C. Instead, we'll call it A. Why does this one have to be C? It's the longest, and it's across from the 90-degree angle. So always important that you make C that longest side. It's called the hypotenuse. So I set it up. A squared plus B squared equals C squared. Do you know A? A squared. Do you know B? Do you know C? Oh, gonna need to square that. I don't know what 6.4 squared is. So I'm gonna go to my calculator and I'm gonna type it in. I'm guessing it's around 40, but who knows? 6.4 squared, 40.96. Is everybody okay with that? 40.96. 10.1 squared. I know what 10 squared is. What's 10 squared? 100. And so it's going to be probably a little bit more than 100. We'll figure out exactly what it is. 10.1 squared, 102.01. Very good, Blake. Blake, yes. Question, Jared. Good question. You don't have to have parentheses around it. I just wanted to make sure people saw that you're squaring the 6.4 and not just the 4. See what I'm saying? So, but I really didn't have to write it, so I won't do that in the future. Good. Blake said, let's subtract the 40.96. Very good. I'm going to subtract that 40.96. And I get a squared is equal to 102.01 minus 40.96. And I get 61.05. Is that my answer? Do you think that this side right here is 61.05? If that side is 6.4 and that side is 10.1, then this is 61.05. What do you think? Why is that impossible? Because the longest side, Shadir has it perfectly correct, the longest side is 10.1, so this can't be more than 10.1. So what am I going to do now to find A then? Take the square root of that. Very good. So we're going to take the square root of that. So the square root of 61.05. And I get, this is where we'll round to the nearest tenth. 7.8 we'll call it. Yep, 7.8. How's that? What do you think? Introduction Pythagorean Theorem? I want you guys to understand, like we took a quiz on 5.7. Like we're not going to go to 5.8 and 5.9 and then chapter 6. What I'm saying is let's take a little break and let's do something that we can all understand. Pythagorean Theorem and something we call the distance formula. So I want to do that to make sure everybody understands something before we move on to other stuff. Because I'm kind of tired of graphing lines and slope and that stuff. You guys tired of that too? So we'll take a break and do something else for a little while. We'll have to get back to it. But right now we want to do something we can get. And I think you guys can all get that. Okay, here you go. I'll pause and finish off this video. Excellent. So for people watching the video, here's the first 3 problems worked out by our 8th grade algebra class. Excellent work. All 3 of those are correct. You could continue with problems 4 through 9 on the front, and then you can continue work 10 through 21 as well. But we're not going to get to this backside until for sure tomorrow, and you're going to have time to even finish up that other stuff as well. So let's work through the rest of the hour, and we'll move along. Okay.